So, ladies and gentlemen, we can also solve systems of equations by elimination. So, of the three methods, graphing, substitution, and elimination, this video cast will show you how to solve systems by elimination. Remember that any systems of equations can be solved by any of the three methods, and a system of equations is a pair of equations for a pair of variables that it permits us to solve for both of those variables. So if we have two variables, we need two equations to solve a system of two variables. If we happen to have three variables, we'll need three equations to solve for those three variables. We'll focus primarily on just systems of equations that involve a pair of equations to solve for a pair of variables. So let's start with this first step for solving systems by elimination. The first thing that you're going to do in the first step is to identify variables that have matching coefficients. That's going to get a little bit more complicated in just a moment, but for now we're going to focus on situations where we have matching coefficients. So here it's clear to see that we have a 1x in the top, a 1y in the top equation and a 1y in the bottom equation. So those indeed do have matching coefficients. Here are some examples, though, of other matching coefficients that are different than 1. So this top equation has a 2p, and the bottom equation has a 2p. So the p variable does have matching coefficients in each of those equations. Then in this set of equations, the n variable has a coefficient of 15. This is positive 15 and this is negative 15. However, we would still be able to use elimination because the absolute values of those are the same. So you'll see how that works momentarily. So let's go back to our original equation, which was a simpler setup where we knew that we had two y's and a coefficient of 1 on each of these y values. So in this case, we can simply subtract the entire second equation from the first equation. Be careful, however, because this subtraction sign will have to be applied to each one of these parts of the equation as you make this subtraction of one full equation from the first. So y minus y is clearly 0. Minus x minus 2x will give you a 3x, and 1 minus 4 will give a negative 3. So subtracting these two equations gives us the equation 0y minus 3x equals negative 3. So take a minute to look at that if you need to. So stop the video and make sure that that makes sense if you need to. Next, we need to ensure that x is by itself. So we will divide both sides of this equation by 3. I hope you see that this y variable goes away because if we take 0 times y, we have no y's in this equation. So this equation written here in black, this part without the divisors of negative 3 on it, is the same as the equation above it. So now as we divide by negative 3, that will enable us to get a coefficient of x all by itself with just a coefficient of 1. So when we solve that, we see that x is equal to 1. We then take the x equals 1 that we just solved for and substitute it into one of the original equations. I chose the y minus x equals 1 because I think it's a simpler equation. So when I drop 1 in for x, I get y minus 1 is equal to 1. So in order to solve that, I need to add 1 to both sides so I can see that y is equal to 2. So now I have the two solutions, x equals 1, y equals 2, and I will give my answer in an ordered pair. So my solution will be given as 1, 2, the ordered pair 1, 2. So there's that one. Next, let's think about something else that could come up. What if the problem you were asked to answer provided the same two equations, but the prompt asks you to solve this system of equations for y. It would have been fine to go through the process we just went through and solved for x and then solved for y. But we could manipulate these equations so that we could solve for y directly. And sometimes we'll also be able to use this process to manipulate two equations that it doesn't look like we can solve by elimination. So what we'll do in this case is we're going to target these x values. And we want to make the x values match. And we know we can do that by introducing a factor. So the second equation has a factor of 2 on the x value. So it just makes sense to look back up here and ask ourselves, how can we introduce a 2 in this equation and keep it still an equation? So we're going to introduce a factor to create variables that have matching coefficients. And I've explained that what we're after is a 2 on the x. So we're going to start with this equation and say, well, I want to have a 2x in this location. So if I multiply both sides of this equation by 2, then I will have 2y minus 2x is equal to 2. And at that point, I can combine this equation with this one. So I'm going to just temporarily eliminate that one and focus on the new one that is the same equation. It simply has a factor of 2 added across all of the elements of the equation. But I can clearly add those two equations and eliminate the x variable now. So when I add these two, a negative 2x plus a positive 2x will mean I have no x term in the solution. I'll begin over here and I'll add 2y to y and get 3y. These two variables, when added together, will give us a 0, and 2 plus 4 is 6. So I essentially have 3y is equal to 6. If I divide both sides of this equation by 3, then I see that y equals 2. If my original prompt was to solve the system of equations for y, then I'm finished now. It didn't ask me to provide the x value, so it's not necessary on this one to provide an ordered pair. If it had said solve the system of equations, then I need to provide the answer for x and the answer for y. But since it asked me for just the system of equations solution for y, then I'm finished by just saying y is equal to 2. So to summarize the steps, when we're solving by elimination, if we can identify variables that have matching coefficients, then we can start there. That was like our first example. Or if we don't have matching coefficients, then we can introduce a factor to create variables that have matching coefficients, and then proceed with steps 2 and 3 in the same way. We'll add or subtract the entire equations to eliminate a variable, and then substitute the value that we solve for in number 2 into one of the equations to solve for the second variable in our step 3.